So there we go. And so this time we're going to have two parts. I'm going to do the first part on fairness and bias in NLP, and then we're going to be talking about computational social sciences and application. These are related topics, but not the same. One is more on building systems and ensuring the systems we build are fair and help, basically doing well for everybody they're intended for. The second one is more on uncovering things about society through NLP. So I will reopen that. Let's get started. So first, I'd like to talk a little bit about why we build NLP systems in the first place, or actually why we build any technology in the first place. And usually it's because we have some sort of problem that we would like to solve, or some sort of thing that we'd like to make better. So in this particular case, the person in the blue speaks Japanese, the person in the red doesn't. So the person in the red has a problem. So what we do is we build a technological system that tries to improve the life of the person in the red by translating into English, which they understand, so they know where they need to go to the bathroom. So we want to make the world a better place. At least that's a lot of the motivation. And one question is, how do we quantify better? And I did a minor in economics, and one way we quantify this in economics is through a concept called utility, which is basically the total satisfaction received from consuming a good or service. So if we think of NLP technology as a good or service, or some sort of something that's contributing to a good or service, then we could measure this through the utility derived by using that technology. So one problem is that our systems don't work equally well for everybody, or they may influence people in disparate ways. And because of this, this results to an unequal allocation of utility and unfairness in our systems. So there's a lot of different ways that this could cause problems for people who are using an NLP system. And I've just listed a few of them here. So one very obvious example is that different people derive unequal utility from NLP systems because they work better for some people than others. So as an example, I'm an American English speaker. I speak more or less kind of the American English that tends to appear in training data, let me put it that way. So a lot of training data has an accent that's very similar to mine, mannerisms very similar to mine. So because of this, a virtual assistant would be able to understand my speech probably as well as it would just about anybody's. I have a little bit of an accent. I don't know if people can tell. It's not the standard American accent. I'm from Michigan, and we have a little bit different, but it's not enough that most people in this class can know. So.
I consider that standard.
It's pretty close to standard. We speak through our nose a little bit more than most people in the US, but still, it's close enough. So because of this, I can use a virtual assistant, card navigation system, translate the text I write, benefit from good search technology, etc. If we think about somebody who speaks Japanese, they still do pretty well, right? Because Japanese is a relatively high resource language. A lot of, companies, multinational companies have this as one of their first markets that they aim for. And there's a lot of Japanese companies working exclusively on Japanese too, of course. But what about Marshallese? So Marshallese is from the Marshall Islands. This is the president of the Marshall Islands, by the way, and the mayor of Tokyo. Basically, they don't use the above technology, or they're forced to use it in a second language because there's no technology for Marshallese, and maybe they speak something else. If you are using it in a second language, then you would be a non-native speaker, or maybe even just a native speaker with a different accent than the training data. So if the training data is trained on American English that sounds like my English, and then you test it on somebody who is from Singapore, for example, they're native speakers of English very often, but they have a very different accent than I do, and it's not going to work as well for them. Another potential harm is something that's called allocational harm in a lot of the literature on the topic. And basically, decisions made by an NLP system can affect people in different ways. So an example of unfair positive allocation would be, let's say we have an NLP system who decides who gets a loan or who is accepted into a university or something like this. We don't have this in CMU, but like, let's say there was a system that read your essay and decided whether you should be accepted or not. Let's say that doesn't work very well. And it's fitting on surface features or something like this. And then people who write things that fit those surface features get accepted, and people who write things that are just as deep or something like that, but don't fit those surface features would not. So that's unfair, obviously. Yeah. Resume filtering. So here's an example. People would embed the names of famous universities in their resume in white font to pass keyword filters. So it's like, number one, why do you have a keyword filter on a university in the first place? Number two, it's not a very good one if you can embed something in white font and pass the filter. So on the other hand, there's also unfair negative allocation, or unfair allocation of negative utility, which is basically an NLP system decides who gets arrested due to their social media posts. And this is a real example where somebody was posing by a bulldozer and said good morning in Arabic, and that was translated into attack them. And then the guy was arrested. So like, this is maybe one example. There might be other things like filtering social media posts for things that look like, terrorist threats like this or something like this, where if it fails and somebody gets arrested, they might be falsely charged or something. And these are just some examples, Another potential harm is when a system reflects harmful societal biases in its output. To give just an example, Turkish has, in these examples, doesn't have gendered pronouns. So when you translate from Turkish to English, where English uses a gendered pronoun, you can see which one Google Translate picks. And it picks things like, for cook, it picks she, for engineer and doctor, it picks he, nurse, it picks she. So actually, Google Translate has improved on top of this recently. So basically, when they don't have very good, evidence for which one it should be, it just outputs both, like he, she, or something like this. But it still doesn't work in all cases, and you can still see mistakes like this. And other things like language generation systems all show these sorts of biases. Sometimes they're even worse than this. There's also bias in human annotation. So for example, if you ask humans to annotate things, and you ask them to annotate whether something is hate speech, people who do not fully understand the speech because they don't belong to the community that it is targeted towards can make mistakes and say something is hate speech when it's not, for example. And it can arise from underspecified annotation guidelines and having different cultural and social norms. So there are some examples of this as well. Okay, so like 20 years ago or something like this, when we were talking about NLP, or we might not have worried about this quite as much, but now NLP is used in everything, right? And it has real impacts like the ones I talked about. So it's something that we need to be very careful about. So detecting biases in NLP systems, there's a number of techniques to try to do this. For example, association tests, analyzing performance measures across groups, and counterfactual evaluations. So there's something called the word embedding association test. And basically, word embeddings learn relationships derived from co-occurrence statistics. One very famous example of this is, if you do king minus man plus woman equals queen. So king and queen in man and woman are things that kind of by definition are gendered words, right? The definition of a king is a male ruler of a country, of a monarchy, and the queen is a female ruler of a monarchy. However, if you do the same thing, like you do doctor minus man plus woman, you end up getting things like nurse. And this is not by definition gendered, right? This is just an artifact of either current, current trends in society or even past trends in society, because a lot of our training data might not have come from the present, and it still can reflect previous biases. So the way the word embedding association tests work is you have two sets of target words. So you have things like programmer, engineer, and nurse and teacher and stuff like this. And these words are basically chosen to, they're chosen to be things that are not inherently gendered, but traditionally had a trend of being gendered or were stereotypically gendered, for example. We also have sets of attribute words, which are inherently gendered words. And the null hypothesis is that there would be no difference between the two sets of words in terms of the similarity between them. So this would be if there was no gendered things. Yeah, thank you. I'll handle that later. Not yeah. And so the mathematical formulation is basically what we want to check is what something that looks like this, where SWAB is the association with the attribute, and it's the mean cosine similarity between words in between the word itself and all of the words in the class A, and the similarity between the word itself and all of the words in the class B. And then the thing up here is the differential association between the two sets of the target words. So basically, if there was no difference between them, we would expect this to be very close to zero. If there's a significant difference between them, we'd expect it to be larger or smaller. So this is an example from this test. And this is the strength of the association of occupation words with the female gender. So this is the percentage of workers in the occupation who are women. And you can see that there's a pretty strong association between this. And there's also an association between names and the things in the, like gendered words, essentially. So what this is showing is basically there's a very clear trend that if there are more people in the occupation, then the word embeddings are more closely associated. So why would this potentially be an issue? Like, let's say we were training a model that was based on word embeddings to decide whether somebody was appropriate for working in a particular job. It would be bad and illegal to consider their gender while you're doing this. But if the embeddings we learned in this case are inherently, gendered in this way, then it's a very natural conclusion that this would, upweight people who are female for, typically female-oriented job, and upweight people who are male for a typically male-oriented job. And not only that, what if you had a female-sounding name or a male-sounding name? So a similar thing could happen. And these can also be extended to sentences. So basically, right now we don't use like static word embeddings as much anymore. We now use contextualized embeddings like Elmo or BERT or things like this. And a similar way you can do this is you can add basically a semantically bleached sentence, like this is X, X is here. So this has no, gendered information whatsoever. It's a very standard sentence. And so then you can embed the whole sentence and look at the embeddings for the words or the sentence itself and examine whether this shows a similar trend. And interestingly, the kind of contextualized representations display less evidence of association bias compared to the older models, but still they demonstrate bias. So these were very interesting works that kind of pointed out a problem. There are a few issues with them, however. The first one is that they have positive predictive ability, but they do not have negative predictive ability, or they do not they have no way of giving evidence of lack of bias. So what you can show is you can show that there is bias, but you can't show that there is not. And yeah, a lack of evidence of bias is not a lack of bias. Another issue is that bias in word embeddings, if you have bias in word embeddings themselves, there's not necessarily evidence that it will propagate to downstream tasks. And even if it seems like this association test doesn't pass, it still might propagate to downstream tasks in unpredictable ways. So one thing that people do instead is analysis over error rates. And in the US law, so discrimination is very heavily, regulated against in US law. And, these issues of bias and other things require, there are some requirements in law that basically require you to not do things that adversely affect one group of people of a protected characteristic more than another, even unintentionally. And so algorithms exhibit impact disparity when outcomes differ across different subgroups. So for example, if somebody speaks a different variety of English, or somebody has a different name, or something like this, you would not be allowed to have an NLP system that impacts them disparately. And one way to identify this disparity in NLP systems is by comparing performance measures. So error rates, false positives, false negatives across groups. And just to give a very obvious example from 2020, impressively, which is only 1 year ago, we can see that this work basically examined 5 ASR systems by Amazon, Apple, Google, IBM, and Microsoft. And there were 42 white speakers, 73 black speakers, and they averaged the word error rate for black speakers. And they took the word error rates for both of them, and the average word error rate for black speakers was 0.35 compared to 0.19 for white speakers. So, if this is not a disparity, it's across 5 systems from leading tech companies. This is pretty obvious that this is an issue. So similar disparities were observed between predominantly African American cities in gray and predominantly white cities in white. So you can even see that it's reflected in geographical statistics as well. So another thing is cross-lingual disparities in NLP tasks. So what I was talking about before was all for English, just different varieties of English. And the differences are even more stark when you start talking about people who speak different languages. And these graphs are from a paper that we released recently about cross-lingual disparities in NLP performance. And basically, we can see for things like speech synthesis, we have very good speech synthesis for English. And it gets gradually worse until we get down to the less well-resourced languages. And the big white bar on the right here are languages where we don't even have any reported results at all for these languages. And this is done by world population. Like, for example, English would have a big bar, Chinese would have an even slightly bigger bar. English would have a big bar, Chinese would have a big bar, and other things like that. And then, so basically the fact that approximately 40% of this here is white means approximately 40% of the native languages of speakers in the world are not covered by speech synthesis technology at all. So this is a big issue of impact disparity as well, obviously. So the final way of examining bias is counterfactual evaluation. And one thing that's kind of nice about this is this allows you to drill into different impacts of individual like words or individual decisions in a very controlled manner. And so the way this works is basically you modify text by flipping protected attributes and observe the differences in model performance. So in this particular example, this is in a task of co-reference resolution, which is basically trying to identify which thing refers to which other thing. And the sentence is, the surgeon couldn't operate on his patient, it was his son. The surgeon couldn't operate on their patient, it was their son, or the surgeon couldn't operate on her patient, it was her son. And basically, the issue here is that when you have this on with like a male pronoun, it appropriately gets the surgeon and his patient. But when you have a female pronoun, the co-reference system like basically wrongly predicts that it is co-referent here. So this is demonstrating that even this co-reference system has a bias towards like the link between gendered occupations and other things like this. So this is called the Winnow gender schema data set, if you're interested in looking at that. Okay. Any questions so far? Yeah. Yeah, so that's a really good question. To repeat the question, it was basically like here, all of the examples that I gave were biased based on protected attributes that we know are not, we're not supposed to be discriminating along like things like gender or race or other things like this. But what if we don't know a bias, don't know of a particular bias being present in the data set? I think that's really interesting. I think the difficulty, perhaps the difficulty there is, what if people talk about certain topics and the results on certain topics are worse than others? Is that discrimination or not? It's kind of hard to say. Like, where do you draw the line between something that's discriminating based on something you shouldn't be discriminating on, versus just some topics being harder than others, like topics about natural language processing being easy because it's obviously so easy, right? And then medicine being hard or something. So I think it's an interesting question, though. I'm not aware of very many things like this, although I did talk earlier about distributionally robust optimization. And distributionally robust optimization, the basic idea there is that you're trying to create models that do well on like all subgroups, regardless of the subgroup division. And so those models, at least theoretically, could handle biases that you never thought about before. But yeah, I think it's a really interesting question. Anything else? Okay. So now we'll go on to work on mitigating biases. In mitigating biases, there are ways to mitigate, but it's just mitigate. It's not completely remove in any way. So there's automated mitigation strategies. There's also careful data creation and augmentation, balancing groups, diversifying data, and also having humans in the loop of data creation or feature feedback, etc. And one particular way that can be used here are things like feature invariant learning. I'm actually going to be talking about this a little bit more in a later class, but the idea is basically that you train a model that tries to create intermediate representations where you cannot determine the original protected attribute. And we use methods like adversarial learning for this. And as I said, I'm going to go into the details later, but basically you train a protected attribute classifier and try to learn representations where you can't identify the protected attribute. So one interesting thing is that even with adversarial removal of information about protected attributes, demographic information can still be recovered even after adversarial training. So basically the reason why this is the case is because the adversary is trained in a particular optimization process. It gets to a certain point where you're able to fool this particular adversary that you trained, but there's also if you retrain a separate adversary, it's still able to identify information about the protected attributes. So there's also methods that kind of iteratively remove the information about the protected attributes as well. There's also work on debiasing word embeddings. This is a very famous paper that kind of started interest in the field. And so the way this works is we identify a direction of the embedding that captures bias. And so the way you do this is you basically come up with like a set of words like male, female, man, woman, waiter, waitress. And you find the average vector direction between these two like pairs of gendered words, and then you try to remove, you formulate this as a subspace and try to basically project pairs of words that are not supposed to be gendered so that they don't differ along that dimension, essentially. You can do this by neutralizing. So the gender neutral words are 0 in the gender subspace. You can make sure that any neutral word is equidistant to all of the words in each equality set. So like make sure that all words like nurse and doctor are equidistant to male and female. And you can also reduce the differences between equality sets while maintaining as much similarity to the original embedding as possible. So they demonstrate that basically you're able to remove bias or reduce bias to some extent. However, there are issues like what if you have something that is really only used in a single way, like grandfather or regulation. This is like a set term in English. Should this be equally probable as grandmother or regulation? Maybe so, maybe not. It depends on your application. However, there's also very interesting work on how debiasing methods cover up systematic gender biases. So for example, despite the fact that you've run these gender bias methods and you can demonstrate that things are equidistant from particular words, or you can demonstrate that they don't differ along an axis that corresponds to gender, nonetheless, embedding clusters can align with gender 85% of the time. So this can be an example. We have a cluster of kind of male biased words and female biased words, or vice versa. I forget which one it is. But still, if you cluster them into clusters, or you project them down to an embedding space through like an embedding projection method like TISNE or PCA or something like this, you still get essentially an identical result. It's like maybe these clusters are a little bit closer, but still, female-oriented words are closer to female-oriented words, and male-oriented words are closer to male-oriented words. So, are there any questions about these techniques? Basically, the idea is you try to remove particular dimensions or particular features in the embedding space. But yeah. Yeah, so that's a good question. So instead of being unable to distinguish, can you train a model so that it, despite the fact that it is able to distinguish between the groups, it makes sure that there's not advantages or disadvantages between them? Yes, that's kind of like one of the goals of the things like the counterfactual evaluation here. So the idea being that you would like, if you flip the gender of the pronoun here, you should have no difference in the like performance of the system on the task that you're interested in. So yeah, that's definitely a thing that you can do. In order to do that, curating training sets is one important thing, and that's actually what I'm going to talk about next. So the next thing that I'm going to be talking about is automatic data augmentation, or even manual data augmentation. And basically the idea of this is that you can programmatically alter text to invert gender bias, or to invert the gender of words and make sure that the model is trained on trained on sufficient numbers of examples from each. So for example, the doctor ran because he is late can be augmented into the doctor ran because she is late. Both of them are still valid sentences. And one difficulty with this is you have to very carefully, decide how to augment data, and you're probably going to miss something, right? You can't think of all the possible ways that gender or whatever else might interact appropriately, like names, for example. If you have a gendered name, how do you handle things like that? And so you can also, one other thing that makes it even more difficult is, like, let's say you have language that very heavily marks gender in its morphology. So like, for example, English, it doesn't do it so much, but in other languages like French or Spanish or something, you might have different genders depending on the like name or something. Sorry, different gendered conjugations depending on the gender of the person who is a doctor or something like that. You can also mitigate these biases with humans in the loop. So basically what you do is you ask humans to edit documents in the appropriate way. So here we had automatic augmentation. In this particular case, you can just ask humans to go in and directly augment the data. And one of the interesting things about this is there are examples where there's very obvious spurious correlations. So this is an example from a sentiment classification data set. I think I mentioned this earlier in the class as well, but basically romance movies tend to get a high rating and horror movies tend to get a low rating. And that's just the fact that people who watch romance movies are probably in a better mood than the people who watch horror movies, I guess. So if you train a regular classifier on a regular sentiment analysis data set, you will get something like romance is a high scoring positive sentiment word. So what they do here is they go in and they ask humans, okay, can you make the minimum change to the sentence to turn the sentiment label from positive to negative. And if you do that, then basically this will flip the labels. This will flip the labels without flipping, for example, the genre of the movie. So now if you flip the labels, now horror is a positive attribute, romance is a negative attribute, and then if you train on both of these data sets, you get these kind of genre-related words falling out. So this can be used as a general tool to remove bias, but it could also be used as a tool to take in something with a gender dissociation and ask humans to say, okay, now take the story and pretend like this person was female instead of male or something like that. Okay. Any questions about these things? Yeah. So, yeah, very good question. Is the bias problem like a domain adaptation problem? I'd say yes and no. The problem of disparate performance across different groups is maybe in a way like a domain adaptation problem, in that you can view the data or like the language created by people of different groups as different domains. So in that way, largely yes, a lot of the similar techniques can be used there. For other things like gendered pronouns being indicative of particular occupations or something like this, I think this is a different problem and requires a different set of tools. Okay, so finally, I have something about what are we doing wrong here. And this paper is the highly recommended reading on the website, if people have noticed. This is a really, really nice paper because it's talking about different, it's kind of a meta-analysis of bias, things regarding bias in NLP, and they basically survey 146 papers analyzing bias in NLP systems. And they found that despite the fact that the overall goal is, admirable, like making fairer systems, they found the motivations were often vague and inconsistent with, so basically the methods proposed were often inconsistent with the original motivation stated. And also, bias is mostly a problem when it hurts people, right? And when people get hurt by having a bias system, that's a major problem. But often the harms caused by bias weren't specifically laid out. So this gives a very good overview of the field in general, and also kind of gives some guidelines if you want to work on things in this area. So yeah, here are the guidelines here. And another important thing is that well-intentioned work can have dual impacts. So this is maybe moving beyond bias and all the way to kind of just ethical development of NLP systems. But for example, advanced grammar analysis can improve search and educational NLP, but it could also reinforce prescriptive linguistic norms. So for example, it might try to correct people's grammar that is appropriate for their subpopulation, but not considered appropriate according to whatever standards that person came up with. Stylometric analysis can help discover provenance of historical documents, but also unmask anonymous political dissent. Text classification can identify information of interest, but also aid censors. So these are just some examples of how the stuff that we create is, maybe doing the things that we want it to be doing, but also potentially having negative impact. And I really, really like this, this figure that I discovered maybe 5 or 6 years ago. And it's from a description of persuasive technology. And at that time, I was working on persuasive dialogue systems or negotiation dialogue systems. And basically, the idea is if you look at the outcome, If it's your intended outcome and it's ethical, that's great. If it's your intended outcome and it's unethical, then, I mean, you probably have an ethical problem. But the more difficult thing is if it's an unintended thing, if you can reasonably predict that this might be an outcome from it, and it's an unethical outcome, you're still responsible. So you still should be thinking very carefully about this and mitigation strategies and stuff like this. So it's not good enough, morally, at least from my point of view, it's not good enough morally to say, well, that's not what I built it for. It's, if you know somebody might be using it for that, then you should be thinking about how you can avoid that. Okay, great. I don't want to use up all of Anjali's time, but are there any quick questions before we move on to the next part? Okay, great. So Anjalie, we'll have you go next. Let me turn on my speaker.
All right. Hi, everyone. I obviously can't see what's happening in the room. So if there are any questions from people in the room, I will trust Graham, I guess, to stop me. I'll try to keep an eye on the chat and participant list for the people on Zoom. I'm going to talk a little bit about NLP methods and applications in computational social science. And the reason I'm talking about this is because this is one of my main research areas. So to people who I haven't met, I am a PhD student at LTI, physically in Seattle. I work with Yulia Svetkov, who recently switched institutions, but I'm a PhD student at LTI. So I'm going to start with just kind of defining what is computational social science, because as sort of Graham said, I think that this concept is often mixed up a lot with sort of other areas. And then I'll talk about some of the methodology, just kind of some examples of methodology. I'm not sure that we'll get through all of it, but we'll get through what we can. So what is computational social science? The definition that I pulled here is from a paper that's written by Hannah Wallach, who is a researcher at Microsoft Research, who has done a lot of work in this area. And Hannah Wallach defined it as the study of social phenomena using digitized information and computational and statistical methods. So this is kind of the definition that I have in mind when I'm thinking about computational social science, is that the idea is that we're building tools to be able to understand kind of things that happen in society. And to be a little bit more specific, we can think about how some of the kind of questions that occur in social science are different from some of the way that we often look at problems in NLP. So it'll look at kind of some example questions that people might ask. On the social science side, a question that someone might be interested in examining is something like, when and why do senators deviate from party ideologies? An NLP person who's kind of also looking at senator voting records on the same data set might be perhaps more interested in a question like, how many senators will vote for a proposed bill? As another example on the social science side, we might be interested in analyzing the impact of gender and race on the US hiring system. And on the NLP side, we might be interested in predicting which candidates would be hired based on their resumes. And one last example, so on the social science side, we might want to examine to what extent recommendations affect shopping patterns as compared to other factors. But on the NLP side, we might be actually interested in kind of building those recommendation systems and understanding which products to recommend to people. So if we try to summarize some of the trends here a little bit, and I am generalizing a lot here, like certainly there are different types of problems in NLP as well. But ultimately, like a lot of times what we're interested in more social oriented problems is explanation tasks. So understanding why and how things happen. Whereas a lot of times in NLP, we're working more on prediction tasks. And I'm going to walk through, so I'm going to kind of give a more specific in-depth example. And this is a paper that is actually not out yet. It's sort of, there's a copy available, but it's unpublished working paper. So it's kind of very new, hot off the press work. And for that reason, so I want to add like a little bit of a disclaimer. So one of the things that I like a lot about reading for me, it's mostly political science work, is that these papers are often kind of very, very thorough, like much more thorough than we often see in NLP papers, and that there's kind of like pages of literature review and lots of analysis. And this paper is not the best example of that because it's not really a complete paper yet. But what it's focused on is looking at manipulative tactics around released particularly by kind of campaigns around the 2020 US election. So I think this is kind of a fun topic, especially given that there was an election in the US just 2 days ago, so it's kind of very relevant. And what these researchers did was they assembled a corpus of over 250,000 political emails that were sent by more than 3,000 campaigns and other kind of fundraising organizations to people who signed up for email lists during the US 2020 election cycle. And what there's sort of a lot of questions that you could look at with this data, but one of the things that they focus on is signs of political manipulation. And this is something that we sort of know happens a lot. There's been a lot of focus in the last couple of years on micro-targeting, especially on things like social media and like where ads are run on Facebook, things like that. But not a lot of work has really looked at emails that are kind of sent by these campaigns. So what are these election emails? I don't know that everyone kind of knows what they look like. So this is an example of one. This is sent by Joe Biden's campaign. This is an email from I think like yesterday. So it's sort of about the election results on Tuesday. And it kind of starts with some like generic, like, oh, like we're all friends and hey folks, and let's like chat about this. And then if you scroll down enough, usually you get some donation requests and it ends with, so please give us money. And the way that the researchers in this project collected data is they started with lists of candidates who were running for office and other kind of funding agencies. And they looked at not just presidential candidates, but all kind of state and federal elections. So also things like people running for Senate, running for governor, running for state legislatures. So they pulled like kind of thousands of these websites and they built a bot to sign up for emails from each website. They use gender neutral names at sign up. This is kind of important because like if you use different names, you might get kind of different emails. And they also used a distinct email address for every website. So for each place they signed up, they created a new email account. And then they also built a bot to actually open and deal with receiving these emails. So once an email is received, they have a bot that opens each message exactly once. If there's a confirmation link in the message, it clicks on it. And then it downloads all resources, including things like tracking cookies, and takes a screenshot of the message. So this is something that like, this is just like kind of a crazy amount of engineering work that went into collecting this data set, like building this like data collection method that involves kind of both doing the automated signups and finding forms on websites and filling them out, but then also handling the email receiving and then taking into account, like you can see that there's kind of a lot of care that went into it. Things like they want a different email address for every campaign that they sign up for. They only open messages exactly once because campaigns track how often you open messages, and so they want that to be consistent across all of the places where they're collecting data. And there's a lot that you could do with this data set, and this is something that I think is kind of exciting, that there's a lot of potential here that's sort of untapped. These are some of the questions that they look at in the paper that they've released so far on this data. I'm not going to go through all of them. I'm just going to kind of look at the first two, which is sort of what are the topics discussed in these emails, and what strategies do these emails use to encourage people to donate and to do fundraising. So regarding what topics are discussed, the main methodology that the researchers use to look at this is a topic model. Specifically, they use a variant called a structured topic model. I'm going to talk a little bit more about this later, so I'm not going to go in depth on the methods right now. But they look at across these kind of emails from different campaigns, what topics do they talk about? And this is something that they sort of say like, oh, kind of as expected, we see similar topics, similarly mentioned rates of coronavirus pandemic in emails, both from Democratic and from Republican campaigns, but we see different levels of mention of other issues that are kind of more traditionally left-leaning or right-leaning. So things like Black Lives Matter, police and racism, or the economy and economic concerns. I actually thought that was pretty interesting because it's very not obvious to me that, say, Democratic and Republican campaigns would mention the coronavirus about the same amount. I maybe like would not have expected to see that, but that is what they find. And one of the second questions they look at is, how do senders overcome fundraising fatigue? So the idea being that in election cycles, kind of loyal voters and donors are asked for money over and over and over again. And so how do you kind of ask for money in a new way in order to get someone to donate, especially if kind of they've already donated? And here they use kind of a combination of methodology. So they do a fair amount of hand coding of examples. So they start with just like taking samples from their data and just reading them and seeing what they find. They do as well, then they kind of look at larger samples of the data set using more automated methods. So one of them that they do is they build supervised classifiers from the hand annotated samples. Some of the strategies that they're interested in looking at, they can do just kind of through regular expressions, like does the email subject contain this phrase, things like that. So they use kind of a combination of more manual and more automated analysis. And some of the things that they find, some of the strategies that they find that these emails use is, one of them is that often the kind of subject doesn't really relate to the content of the email. So there's some catchy subject line that encourages someone to click on it. And then the sort of further down in the email you get, the less and less relevant the email is to the initial kind of clickbaity subject title, and more and more about just donating money. A second one, and this is something that I kind of learned in reading this paper that I didn't know. A lot of these emails falsely promise donation matching. I didn't know this, but apparently it's actually kind of impossible for a political campaign ever to really, so donation matching is where someone states, if you donate now, like your donation will be matched by a private donor up to this amount. So, you know, you're like doubling the impact of your donation because someone's matching it. This actually is basically impossible in political campaigns because there's like set limits on how much an individual is allowed to donate to a campaign. So like pretty much anytime one of these calls for political donations says that they're doing matching, like it's probably just straight up false. So that's kind of interesting that they find this in these emails, that there's some things that are probably like overtly false claims. And then one of the other things that they find is, one of the other strategies that they use to get people to donate is references to imminent fundraising deadlines that are like, we're nearing the end of the month and we haven't met our October donation goals yet, but like donate before Friday and then so we can meet our goals. And what's kind of interesting is when you look at some of these more finer grained strategies, it explains some of the trends that you see in the larger corpus. So this is the volume of emails in the total data set that they see over time for the period they collected emails. And you can see that it's very kind of cyclical, like there are these clear spikes. And if it's a little bit hard to tell from this graph, but these spikes are almost always at the end of the month. And they say that this strategy of like saying there's some end of the month fundraising deadline almost entirely explains these spikes in email sending. So there's kind of a lot of other dimensions that you could look at with this data. So this is another example of an email that I felt had a lot to kind of unpack. This is an email from the Biden campaign that asks for money, and by the way it asks for money is by calling out Mike Pence's campaign for sending an obviously fake email asking for matching, asking for donations that are going to be matched. So I think that this email doesn't quite fit into kind of some of the strategies that they found. So it's clear that there's sort of a lot more that you could look at here. Okay, I ran through that a little bit fast, but just to kind of try to take some higher level takeaways of like, what do we see in this example project, and how does that maybe differ from an NLP approach to a data set like this? So one of the things that is like challenging in in this line of work is often just defining what research question you're looking at. So you start with this sort of super interesting data set of political campaign emails, but it's not obvious what we care about in those emails. It's really not sure what we want to measure, what are the right dimensions to look at. And once you figure out like what you're actually even trying to do with the data set, that's a lot of the project in itself. That's in contrast to a lot of NLP work. Obviously not all NLP work, but a lot of NLP work is sort of often involves building better models for tasks that have been done before. So a lot of times we're working with like pretty well-established tasks and we don't have to spend a lot of time figuring out exactly what the task we care about is. Another kind of higher level takeaway is that data can be really messy and unstructured. And in the kind of NLP side, when we talk about messy data, sometimes, like a lot of times we're talking about things like noisy text, so that, say, social media text doesn't have as kind of nice grammar as, say, newspaper articles. But when we're talking about this in sort of more real world settings, a lot of times the data is messy data is things like half our data sets was in PDF attachments on emails. And so how do we kind of parse that into something we can actually digitize and work with, and have to do something about downloading the attachments and pulling out all the text from them and things like that. Also in the NLP side, in kind of the same vein of a lot of times tasks are well defined, a lot of times data sets are reused across projects. And so, not every time, of course, there's a lot of work on collecting new data sets, but there is a lot of work on NLP that's sort of using data sets that have been used in prior work as well. One of the other things that is really important in kind of social oriented work is controlling for confounding variables. So making sure that you're actually measuring the variables that you want to measure. And I think we see that in this project in the way that they took a lot of care during the data collection to make sure that they were using things like different email addresses for every campaign that they signed up for. And while this can be important on the NLP side as well, a lot of times, like what we're really kind of focused on is performance on kind of a test set, and not necessarily as much care has to go into making sure that our models sort of exactly picking up on the trends that we want. Of course, a lot of the work that Graham's are presented on in the first half of this class goes more towards figuring out if the models are actually measuring the values that we want, as opposed to sort of picking up on other things. And then finally, one of the things that you see a lot in the kind of the computational social science side is using a lot of different methodology and mixed methods, and often trying to kind of find the same results under different methodology. And so it's sort of good if your results are reproducible and you get the same results with different methods, and that's sort of usually not the case on the NLP side, where you're really trying to look for, say, like the best performing model and not showing that like all models have the same results on your task. Okay, so that was a kind of intro higher level case example. I'm going to run through some of the common methodology that I think is used in social science, and going to do it at kind of a quicker high level, but feel free to stop me if there's questions on any of this. Okay, so before I get like too much in depth there, wanted to kind of front load a little bit some of the principles of so these are 4 principles of quantitative text analysis that were written by Justin Greimer and Brandon Stewart, who are people who do work in this area. And I think it's sort of helpful for thinking about the rest of the methods, is to kind of keep some of these principles in mind. So the first one is that all quantitative models of language are wrong, but some are useful. I think this is a pretty interesting starting point. That's something we often don't talk about, like this sort of base assumption of like your model is going to be wrong from the very beginning. A second is that quantitative methods for text amplify resources and augment humans. So this is sort of the idea that if you're looking at more social oriented work, you're probably never going to have a fully automated method. It's always going to be more about augmenting more manual analysis. And that's sort of something we saw in the earlier project as well, of starting with hand analyses and then doing some automation. Finally, there's no globally best method for automated text analysis. And then fourth, it's important to validate models to make sure they actually work before you use them for analysis. So these are some of the methods that are kind of common in more social-oriented analyses that involve text. I'm going to go through them probably a little bit quickly, but so the first one that I'm going to kind of mention is time series or frequency analyses. And the reason I bring this up is just because I wanted to show that there's like there's kind of often a lot of depth that you can do on the analysis side that isn't necessarily obvious if this is sort of from the beginning. So the example project I have for this is drawing from some of the work that I've done in this area. And in this project, we were looking at strategies for manipulating public opinion in Russian news articles. And the starting point for this data set is a data set of 100,000 articles from a Russian newspaper, Izvestia, that's known to be very heavily influenced by the Russian government. And the pattern that we were looking at is when we see kind of economic downturns in the country, so when the state of the economy, like the GDP or the stock market in the country is doing poorly, what kind of strategies do these newspapers use to distract public opinion from the state of the economy? And the main pattern that we focused on is that when the economy is doing poorly in Russia, we find that the news focuses a lot more on the US. So this graph shows the Russian GDP compared with the percent of articles in this Izvestia corpus that have just the word US, United States. And we see this really strong negative correlation that as the economy does worse, the news talks about the US more. As it does better, the news talks about the US less. And to get a little bit beyond this correlation, like what we're actually interested here is if we can see some kind of potential causal effect. Like, can we see that the US news coverage, as the economy does worse, the US news coverage then later does better? So is there kind of a direction to this? Like first the economy starts going down and then the amount of US news coverage starts going up. So we want to see if this is kind of like a directed correlation. And the method that we use for this is called Granger causality, and it's pretty common in economic studies. And the basic idea is we fit a regression model where we try to use the amount of news coverage. We try to use last month's economic data to predict this month's amount of coverage of US news. So I'm gonna kind of not go through all of this in the interest of time. I'm happy to follow up later if there's more questions. But basically what we're looking at is we fit a regression model where we have coefficients. We learn coefficients that are coefficients on last month's economic data and last month's news coverage and try to predict this month's news coverage. And if we find that these sort of economic coefficients are significantly different than 0, then we can say that there is some directed effect here. And that is what we found in this result. So that first we see the state of the economy go down, and then the next month we see the amount of coverage of news of the US going up. And so this is just one example of kind of a time frequency analysis. There's sort of a lot of methods in time series analyses, mostly in other fields, that are often useful in this sort of social-oriented analysis, and where you can kind of integrate more text models into more text features into these time series analyses. Okay, so the second method that I'm going to touch on very briefly is using classification. I'm not going to go into depth on this one because I think this is something that everyone's probably pretty familiar with. It's something we do a lot in NLP, given some text, classify it into different categories. So instead, I'm going to focus on like why this is often really hard around social-oriented questions. And still kind of running with this example of looking at how much these Izvestia news articles talk about the US. So when we see this kind of pattern of these articles discuss the United States more when the state of the economy is worse, the kind of natural like question is, what are these articles actually saying about the US? Like, why is this a strategy of distraction? It's not obvious why it's useful to talk about the US when the economy is doing poorly. And so the potential approach to like one potential approach to understand this pattern is to do some more text analysis. We want to try to understand like what the articles are actually saying. And the kind of initial idea that potentially seems like the way to go here is to start with some hand coding of articles. So we take articles and we come up with some kind of annotation scheme in order to code them for what they say about the US. Maybe we also want to look at what they say about Russia and other countries. And if we do enough hand coding on some manual samples, we potentially could build enough data to train a classifier in order to look at these kind of portrayals in uncoded articles. So this is a pretty like classic NLP pipeline, I would say. I'm sure someone will disagree with me, but I think this is a pretty standard NLP approach. But there's a lot of reasons why this is kind of really hard. And the reason I'm talking about this project in particular is because we sort of thought about doing this and didn't do it for a number of reasons. And so one of the first ones is that we need annotators who are fluent in Russian. We're working with a set of news articles that are in Russian. And this is maybe a little bit harder than it seems to find. If you are kind of like trying to use a crowdsourcing platform, it's often hard to find speakers in the languages that you care about on something like a crowdsourcing platform. The second is that we need annotators to read full-length documents. So this is not an easy annotation task. This isn't something like read a sentence and say if it's positive or negative. It's quite a difficult task. And that also kind of goes with what are the actual annotations that we want to collect. We're looking at some of the kind of subtle phenomenon of how countries are described in news articles. So we don't just necessarily need annotators who are fluent in the language. We also want ones who perhaps have some knowledge of Russian politics, are going to be able to understand nuances in the text, and then also we're going to be dedicated to kind of sit down and read full documents. So you can imagine that like finding people like this is pretty hard. And there's sort of an added complication here as well, which is we need to think a little bit about who's qualified to do a task like this and what they're asking to do. So this is something that comes up a lot in the subject of hate speech analysis. As an example, like this is just where I've seen people talk about it the most, that for example, if you ask annotators to annotate tweets as being offensive or not offensive, you're forcing those annotators to read lots and lots of offensive language, which is potentially kind of like a mentally demanding thing to ask annotators to do. And in this case, this project that we're working on has the potential to be kind of critical of the Russian government. So there's a lot of reasons why someone who actually is kind of qualified to do annotations like this might not want to do it. And that's something that we kind of need to think about as researchers, like what is the actual task that we're asking someone to do? And are they going to kind of be willing to do that or not? And so what we do in this project is we kind of did a sort of, we basically used a distance supervision approach to take existing annotations in English and project them into Russian. I'm not going to talk about it here. I don't think it's sort of relevant for what we're talking about right now. The point that I wanted to just make with this slide is why a lot of times your sort of supervised classification pipeline is really difficult in more social oriented settings. Okay, so what do you do when you can't use supervised data? There are a lot of unsupervised methods, and one of the ones that's kind of very popular and I think, I don't really remember, is not really talked about much in kind of NLP venues anymore, but continues to be extremely common in computational social science work, is topic modeling. And so the idea behind topic modeling is it's a sort of fully unsupervised approach in which you assume that each document in your corpus contains some mixture of topics. Each of those topics uses some mixtures of vocabulary words, and your goal is to recover the topic and vocabulary distributions for documents in your corpus. So to be a little bit more concrete, one of the kind of most famous topic models that most topic models now, almost all of them are some variant of this model. It's called Latent Dirichlet Allocation. And this is a generative model. So it assumes that you made some generative process to create your corpus of documents. And your goal is to learn the parameters that were used in this sort of fake generative process. So the process, this is the kind of generative story that LDA uses. We only have a few minutes left, so I'm not going to go through all of it. But basically, and this is kind of the sort of canonical way of representing it is through a plate diagram, which is common in this type of model. But basically, what you ultimately are recovering from doing LDA is you consider each topic to be a distribution over your vocabulary, and you consider each document to be a distribution of topics. So you're ultimately recovering, like we call these things topic models, but what they're really recovering is just distributions over your vocabulary. So if you actually run a topic model, and this is one that I ran over a set of documents from the New York Times. Sometimes you get kind of useful topics that are actually things that sound sort of like topics, like you could say number 6 here is probably like economic, tax returns, something like that. Number 8 is maybe legal things, but you also get ones that are kind of like syntax and ones that are kind of junky. So things like number 7 is just sort of pronouns, number 5 is just numbers. And so this is like one of the big disadvantages of topic modeling. It's really great for being able to look at a corpus when you have some new corpus of documents and you don't know anything about it and you just want to have a sense of what's in the corpus. It can be really helpful for that. But you can also end up with these kind of like very junky things that aren't actually that useful and that don't give you much information. So that's one of the why like some of the disadvantages of unsupervised approaches is that like you don't really know, you're not always getting out the values that you want to get. So I'm not going to run through all of this. The other thing that's kind of challenging in an unsupervised approach like LDA is it's really difficult to evaluate if it's actually learning what you want it to learn from the data. So I'll just end with one kind of final example, which is this is something that's become really common and is sort of slowly perhaps starting to take over topic modeling as the common way of analyzing data. And that's the reason I think this is interesting is because it relates a lot to what Graham presented on in the first half. And one of the things that's becoming popular is using word embeddings to analyze how words relate to each other in a corpus. So from this kind of like sort of famous paper, which uses this analogy that's pulled from word embeddings, and finds that the word embedding for man is similar to computer programming in the way that the word embedding for woman is similar to the term homemaker. From an NLP perspective, we say that this is kind of bad. It implies that our model is learning these gendered associations and perpetuating stereotypes. But from more of a social science perspective, this is actually kind of really interesting in that we can learn these social stereotypes from data, because it means if we run these models that capture stereotypes, we can then analyze them to learn more about stereotypes. So this has become a really popular method. There's a couple of papers that use it. This is sort of the first one that I think really kind of took off. It was from 2016. They look at how word usage changed over time and can show things like the word gay has become more similar to the words happy and showy, or less similar to the words happy and showy and more similar to the words homosexual and lesbian over time. There's also ones that kind of look specifically at these sort of occupational stereotypes around gender and race. So this was a paper in PNAS from a couple of years ago. And I will wrap up with that. I know that I kind of ran through a lot of this pretty fast, and so I'm sort of like happy to take follow-up questions offline about any of this as well.
Great, thank you so much, Anjalie, for giving that guest lecture. Thank you. Are there any questions? We're right at the end of the time, but it's a nice opportunity, especially since Anjalie isn't here, physically to ask a question or two. So are there any ones you would like to ask? Individually, I should look at Zoom. Yeah, I see.
Bye. I don't know if you can hear me.
I can sort of hear you.
This where the microphone is?
Yeah.
Oh, okay. I was just wondering, have you looked into gaining insights about social stereotypes from bias in large language models at all?
Yeah, there's been some really interesting work on this. So there's a lot of work that there is existing work that does kind of some of the wheat style do large language models capture social bias? And so that's kind of more the NLP side, is there bias in these models? So I was actually at this Texas Data Conference last week that is sort of a workshop for computational social science, and it's mostly people present not yet published work to get feedback. And there were a couple of people who are working on things like, if you feed a sentence into the model and you mask out the people that it's about, you can kind of infer that the sentence might be doing stereotyping based on what the model predicts. So they actually specifically were using it to look at dehumanizing metaphors. So if you take a sentence that has a word referring to people in it and you mask out the word people, and you can, if like words of different animals are very likely predictions by the model, that implies that the sentence is using some like dehumanizing metaphor. So there is some work on this area, but it's pretty new. I don't know if there's anything like published yet, but I think there will be soon.
Okay, great. Thanks so much again, Anjalie. We're over time, so I don't want to go too far over, but if there's any follow-up questions, Anjalie, can you stay on for a minute or two afterwards in case anybody wants to?
Yeah, I can do that.
Great. Okay, thanks a lot, everyone.